These are the pre-calculus fall 2018 ACP sample problems. And this is the district's version of the sample problems, which will be 20 problems. Give an example for a 28 problem test. The content is going to be similar, and more importantly, or just importantly, the degree of difficulty will be very similar to the actual test. So if you are on solid ground as far as being able to do these levels of problems, then you should be okay on your district ACP here in a few weeks. Problem 1, soccer player kicks a ball at an angle. The height of the ball in feet varies with time and is given by the function, and you have h t equals negative 16t squared plus 33t, where t is the time in seconds. What is the maximum height of the soccer ball to the nearest foot? And what you're going to have here is something that I like to call a domain range. And in this case, since you're dealing with time, you're talking about when and where. Well, I got this, or what. Let me see, let me get this right. Where, or when, what. So you want what is the maximum height. It has to do with maximum. So the best strategy I know for this one is put this in this equation in your graphing calculator. I have a TI Inspire CX calculator, which I pull up right here and go to a graph page. My computer's a little bit slow, so there'll be a little bit of a lag time in this, but that's just sort of the limitations of the equipment I have. So here we get out a graph, and I'm going to enter the function. And here, if we press tab, we get a function here, and we're going to put a negative 16. Instead of using t, I'm going to use x. Negative 16x squared plus 33x. And so if we graph this, and we're looking at the maximum height, so we have this little skinny downward opening parabola, and the easiest way I know to get to this maximum above here is to go to a trace. We go to menu trace and go to graph trace, and we can just scroll to the right, and we see this little maximum thing pop up, and we look down right here, and so we get a 1.03 comma 17. So 1.03 comma 17, that's going to be our coordinate pair. Okay, we want what is the maximum height. So are we talking about x value or y value? Well, we're talking about y value. And it says to the nearest foot. Well, as far as we know, that's going to be to the nearest foot. That looks like a whole number, so that's as good as we have to go on. So if we go here, we say, okay, 17. It says record the answer, fill in the bubbles. And it's going to be positive 17. But what happens is your grid assumes positive unless if nothing's noted there. So you can put in a plus sign here on the left, and the 1, 7 can go together consecutively in any two places here on this grid and still be a correct answer. Next, 2, the Texas Department of Public Safety collected data on stopping distance for a number of different types of cars. They found that one brand stopping distance could be modeled by the equation. So they give an equation, y equals 0.05x squared plus 0.1x plus 5, where y is the stopping distance in feet. Now, you kind of got to be careful on this, because you say 100 feet to stop. Well, it says the stopping distance. So stopping distance is your y value. So your equation that works for this is 100 in place of y equals 0.05 x squared plus 0.1x plus 5. And there's quite a number of ways you could do this. The way I'm going to do this that's similar to what we've done before, I'm going to go ahead and go to the graphing calculator again and put in this equation. And I'm going to press Control I, get a new page, add graph. I'm going to put in 0.05 x squared plus 0.1 x plus 5. And then if we graph this, we're going to see this sort of thing here. Well, we can go to graph trace like we did before. And we're looking for an output value of 100. Well, so you can just scroll all the way up here, and you see where it says that's going to be this value here, where it says 16.8 right now. You just keep on going up all the way to close to 100 and see what you get for an input value. So what input value does it take for you to get an output value of 100 feet of stopping distance? And here we're getting close to it. I know it's a lot of, so we come up here. So 100. So I'm seeing 42.6. So x equals about 42.6, and that's going to be answer choice A, the best answer. One thing you gotta be careful about is don't put your 100 in for x. That would give you probably answer choice C or D. I don't know which. So just read carefully, put the right things in the right places in your equations, and you'll be okay. Problem 3, a radioactive substance, cesium-137, has a half-life of about 30 years. We went over this quite recently. We had the half-life equation is going to be A, which amount equals your starting amount, times our base of 1/2, times, to the power of t over your half-life. Okay, so you got to have a base of 0.5. Anything that doesn't have a base of 0.5 is just automatically wrong, and you should recognize that right off the bat. And what is your starting amount? Okay, the initial amount is 70 grams. Anything that doesn't have an initial amount of 70 grams is also eliminated. There's, see, it says A sub 0 has to be 70, right? So that leaves answer choice B, and you should be able to see that that's the time over the half-life, and the half-life is about 30 years. So B is our correct answer. 4, function shown. Which statement best describes the discontinuities in the graph of f of x? Well, you should be able to see that since you cannot divide by 0 in math or in algebra, okay, that x cannot equal 3. So there is a discontinuity. So answer choice A is out. From here, you can work this problem out just algebraically, which I'm going to do later. But first, I'm going to go to the graphing calculator and get a new page by doing Control I, add graph. And then we're going to put in the equation as written, which is going to be in the numerator x squared minus 9, and in the denominator x minus 3. And then we graph this, and if we go look where x equals 3, we do not see any kind of break. And so if we'd see a break, we'd see a jump discontinuity, or more likely a vertical asymptote. So what that is, that's evidence of a removable discontinuity or point discontinuity, or whole. And that's going to be answer choice D. Okay. Infinite discontinuity would be a vertical asymptote. Okay. So we don't see that. We definitely don't see a jump discontinuity. Just for your reference sake, a jump discontinuity, because there was one on last year's test, is a function that goes something like this, comes along and then just jumps up to another place and goes somewhere else. That's a jump discontinuity, which I just drew. Now, algebraically, this x squared minus 9 in the numerator can be factored to be quantity x plus 3 times quantity x minus 3. And we can see that x minus 3 over x minus 3 will cancel. And that, when you can cancel like that, that is evidence of removable discontinuity. So algebraically, it should be quite easy. Another thing you can do is you can go to your graphing calculator and go to Control T. And even though you can't see graphically the discontinuity on the graph here, you can go down to where x equals 3 and see you have an undefined y value. So the function is still undefined, even though the graph function looks like there is no discontinuity whatsoever. Next 5. If f of x equals x minus 1 over 3, what is f negative 1 of x? And this is called inverse function problem. And for inverse function, there's a 4-step process. Step 1, that I've told you about several times, is change f of x to y. So if we say y equals x minus 1 over 3, that's going to be step 1. Step 2 is you switch x's and y's. So we say x equals y minus 1 over 3. Step 3 is you go about solving for y. Well, if you multiply both sides of this equation by 3, okay, so we multiply by 3, that on the right, 3 over 3 cancel each other. And so what we have is 3x equals y minus 1. And then if we add 1 to both sides of this equation, we get y equals 3x plus 1. And so that would be, in the last step, step 4 is change y to f negative 1 of x. So that's going to be f negative 1 of x is equal to 3x plus 1. And so our answer choice is going to be B. Another thing you look for is when you have a linear function like this, your slope is going to be like the reciprocal of what the original is. So you have x over 3 or 1/3, and so the slope of your answer is going to be 3. And you have a minus here in the original, you can have a plus sign here. And then finally, like to graph these in the calculator is a pretty good way to do it too. Like if you take this Control I, add graph. So we put in what is that? Let me try it again. Control. Okay, we have, I think it's 3x. No, it's x minus 1 over 3. Yeah. X minus 1 over 3. Okay, this is the original function here in lavender. And then you're going to try to reflect this function about the line y equals x, which is this green one right here. So our answer is going to be up here. And so what did we say our answer was? It was it 3x plus 1? I think it was. So we press tab, 3x plus 1. And we can see in orange here that the orange one and the lavender are reflections about this green line y equals x. So further confirmation of B being our correct answer. 6, a function is graphed on coordinate grid as shown. And what you have is the domain has a couple of vertical discontinuities, infinite discontinuities or vertical asymptotes at x equals 2 and at x equals 5, it looks like. And so there are going to be breaks at 2 and 5 on the domain. And then you're going to have an interval. I think A is your only possible right answer, because you have an interval coming from greater than negative infinity all the way up to x equals 2, but not including with parentheses. And then this gap here between 2 and 5, you do have an interval that is counted. And finally, your final interval is greater than 5, less than infinity. And that your range, and it's like I did my little drawing, my little sketch earlier, domain, range. Okay, your range is your y, and your domain is your x. And so A is your correct answer, no doubt about it. Next, 7, if the function f of x equals x cubed is changed to g of x equals x plus quantity x plus 2 cubed plus 1, how is the graph of the function transformed? And we went over graphical transformations very briefly. I had in parentheses here, x plus moves to the left and x minus to the right. So we're going to move 2 left with this 2 here and up 1. So 2 left and up 1 is going to be answer choice C. And if you forget from that far back, it's been a long time perhaps since we've gone over this. So if you take, just graph these in a calculator, we go ahead and put a graph here. We put an x cubed. And so that's going to be our original function. And we want to go ahead and put in a quantity x plus 2 cubed to the third power. And I believe this was plus 1, wasn't it? Yeah. So we're moving the center to the left and up 1. So that confirms our answer choice C. If you miss a problem like this, you're just lazy. Okay, 8, what is the sum of the arithmetic series? And we have a summation symbol here, which is part of our first semester curriculum, but as of this moment today, we have not covered this. It is going to be this week. What I'm going to do is show you, I'll tell you what it is, and then show you how to enter this in the calculator. What this is telling you for an arithmetic series is taking you plug in 1 for k, and then figure out what that is. Then you plug in 2 for k, figure out that is, 3 for k, all the way up to k equals 15, then you add all those together. But fortunately, in our T-Inspire CX calculator, there's a very easy way to do this. If we go to Add Calculator, and we go right next to the 9 key, this little book, you see this menu we have here. And if we go to our second row, all the way over to about here, this is what we see. And we see the summation right here. So we can just start with, just like I said, k equals 1. You can use k, j, or something like that. So we'll say k is equal to 1. And then we can go all the way up to k equals 15. Oops, not 5, but 15. And then go to the right here, we see, let's get that. Okay, we're going to have 3k minus 2. So 3k minus 2. So we get 330. So that's a lot better than just adding these up separately. So that's going to equal 330. Again, that's a positive number. So we don't need to enter a positive in here. And then we bubble in correctly 330. And that's going to be it. On the test, the free response problems, which there might be 3 or 4 or so, they're going to be, most of them, pretty easy problems. So don't be lazy and just fail to do those problems. If I find out about it, you're going to be in trouble with me. Anyway, this one here, f of x equals 3x plus 2 and g of x equals 2x squared, what is g of f of x? Or g of f of -4? Well, f is closest to the -4 is close to the f, so we're going to find first f of -4. So we say f of -4 is equal to 3 times -4 plus 2. And 3 times -4, that's going to be -12 plus 2. That's going to be -12 plus 2 equals -10. And what do we do with this -10? We're going to find g of -10. So we're going to take this -10 and plug it in there for this x here, and we'll have our answer. So g of -10 is equal to 2 times -10 squared. And so that's going to be -10 squared is going to be 100, and times 2, so that's going to be 200. So our correct answer for problem 9 is C. So you're going to see g of f or f of g, either one, or sometimes you can see it written as g of f of 4, of -4. You could see it written like that too. Okay, so there are some different ways of writing these, neither one of which should be much of a problem. And there will be one problem like that. It'll be an easy one. Make sure you get it right. A theater has 35 rows of seats. The first row has 25 seats, second row 29 seats, and third row has 33 seats, so on. So you could say, okay, 25, that's row 1. Second one is 29. Third row is 33. And so that's 1, 2, 3 rows. You can keep on adding. If you add 4, you get 37 and 41, and keep on going till you have 38 of these such numbers. But there's really a faster way to do this that I've been encouraging you to look at. If you go to your Acp Formula Chart, which I have pulled up right here, you have two equations, the nth term of an arithmetic sequence and the one right below it here, sum of a finite arithmetic series. And so to find, we want to find the 38th row. So I'll just put the formula here. A sub n equals A sub 1 plus our common difference times quantity n minus 1. And so if we want to find A sub 38, we put our first row number here, which is 25. And our common difference here is, I hope we can see that the number of seats is increasing 4 at a time. So what we have is we say plus D. D is equal to 4. So we're going to say 4 times n minus 1, and n is 38. So we put 38 minus 1. So it's going to be 25 plus 4 times 37. Okay, let's make A sub 38. So 25 plus 4 times 37. 25 plus 4 times 37. So we get 173. So A sub 38 equals 173. Next, if we look at this formula here, we have this summation, which is going to be this one I'm circling right here. So we have I'm just going to make the little symbol, equals n over 2 times a sub 1 plus a sub n. And in our case, we're going to have the number of rows, which is 38 over 2. And then our first row is going to be 25. And our last row is going to be 173. We're going to get a very large number. This isn't really too practical. So we're going to say 38 divided by 2 times quantity 25 plus, plus 173, and that's what we get, 3,762. That's going to be answer choice A. Now, I know a lot of you, when you do this test here, in a couple weeks, you're going to write down all these numbers here because you'll be able to do that fairly quickly too. Just be careful and be sure of your answer as you do that. Next, the function f of x is graphed as shown. And this has to do with what I call the fundamental theorem of algebra, which means that the number of roots is equal to the degree of the function, and some of the roots may be real and non-real. And I didn't talk about the number of extrema, okay? Well, the real root's going to be, you can count them along the x-axis, 1, 2, 3, 4. So I'm counting 4 real roots. And it doesn't say anything about the type of function it is, cubic or otherwise. You just see those. And so really, just based on what I see, I'm eliminating A and D. And 3 local maxima. Well, we have 1 local maxima, but not 3 local maxima. That would be, we'd have 3 like tops like this. But we have this one down here and this one down here. So those we have 2 maxima and 2 minima, but they amount to extrema. So our correct answer for this one is going to be C. You're going to get a problem as easy as this. You got to get it right. Number 12. The steps Tamisha used to solve the equation 1800 equals 2400 times 21 minus 3 cubed are shown. And what they're doing in these steps is they're combining some things to kind of disguise what they look like. What happens is, as you look at this, you can divide both sides of this equation by 100. And so these zeros will cancel out, okay? And then you can divide both sides of this equation by 6, I think. If you take 18 divided by 6, and on the other side you take 24 divided by 6, you're going to cancel to be 3 equals 4. So you'll have 3 equals 4 times 21 minus r cubed. And if you divide by 4, this is what you're going to get. Step 1. So step 1, even though the numbers don't look the same because of their reductions, there's no mistake there. Step 2, you're trying to solve for r. Well, what you're trying to do is cancel out this 1 minus r. Well, to do that, you take that 1/3 to that 1 minus 3 to the 1/3 power, okay? And this one right here to the 1/3 power. And so what you have is 3 over 4 to the 1/3 power equals just this 1 minus r. So that's a good step 2, okay? So step 2 is a correct step, meaning that that's not our correct answer. And finally, you're just going to solve for r, and if we add r to both sides of this equation, and we subtract quantity 3 over 4 to the 1/3 power from both sides, then r over r cancel, and then so what we have left is r equals 1 minus this thing right here. So that's correct also. So there's no mistake in step 3. So our correct answer choice is D. No mistake was made. I don't know what type of problem you're going to have that looks somewhat like that, if any, but that's what that one is. Okay, 13. The graph of the function f of x equals square root of x is transformed using the given steps. In the order shown, create the graph of g of x. Well, what we could do is we could look at this square root of x and what that thing looks like, and that's one of our parent functions of pre-calculus. By the way, oops, Control I. By the way, I wouldn't be surprised if they had a little parent function problem. Which one of these is a parent function? That's one thing I've seen. So we have square root of x, and it's going to be this looking thing that opens to the right from the origin. Okay, so that's the basic thing. You can kind of see where they are. It'd be like this one right here, right? Square root of x, and so on. So using the order shown, reflect about the x-axis. Well, A is reflected about the y-axis. So that's not even a candidate. And the same thing with D, right? That's not a candidate either. Then vertically stretched by a factor of 1.5, which means it's going to go higher like this. So if we stretch, okay, so we're going to vertically stretch. I think B is your right answer. This is a vertical stretch here. And then finally moved up 1 unit. And this one here is moved up 1 unit from the origin here. Answer choice B. And B would therefore be our correct answer. So you should be able to play around with this. Another thing you could do is you could take this equation like f of x equals square root of x. And if you know what to do algebraically and you want to reflect the thing, you can say, okay, reflects about the x-axis. We'll just make this negative out here. Vertically stretched by a factor of 1.5. So here's the vertical stretch by a factor of 1.5. For say negative 1.5 square root of x. And finally, to translate 1 unit up, we're going to have f of x equals negative 1.5 square root of x, and then just add 1 over here. And then you're going to see this answer choice we've chosen. I'm just going to do it here for fun. Control, I'll just go to tab here. I'm just going to change it. Okay, negative 1.5 square root of x, and then we're going to come out here and add 1. See, there it is. That's our correct answer choice. So a lot of ways to do this. Next, 14. Which coordinate grid represents the graph of the natural logarithmic function? We've talked about the natural logarithmic function when we did section 1.3 at the beginning of the year. Our parent function is pre-calculus. And that parent function of pre-calculus we talked about is going to be f of x equals ln x, which also equals log base e of x. So you can write it in a different way. But in your calculator, you can just graph the function and see what it is. If we go to, I'll just go to tab, and we're going to just make this ln x. I'll show you where that is. if you look at on the left side, this ln above this e to the x, you press Control e to the x, and you put ln x like this, and then you press enter, and this is what it looks like, this red curve here. And our correct answer choice for that one is going to be D. Should be a very easy problem, should you get one like this. 15, what is the fourth term in the expansion of a quantity 3x minus 2y to the 8th power? Now on the ACP test last year, you had one that was a simpler but expanded the 5th power of the whole thing. You can use, like we've done in the class, I showed you how to use Pascal's triangle, where you go like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on, until you get to row 8. And then from the 8th row, you would go over, I'll just go ahead and do it, 1, 4, 6, 4, 1. That's the 4th row, 1, 5, 10, 10, 5, 1. Okay, that's going to be our 5th row, 1, 6, 15, 20, 15, 6, 1. That's our 6th row. One thing you can tell the number of the rows is by what these numbers are here. So our 7th rows will be 1, 7, 21, 35, 35, 21, 7, 1. Finally, our 8th row is going to be 1. 1 plus 7 is 8. 7 plus 21 is 28. And 21 plus 35 is going to be 56. And then 70, 56, 28, 8, and 1. So you're talking about the 4th term. Okay, you're going to be talking about this thing right here. Now, one way you can do this in your calculator, find out which one that is you can go to, I'm going to go to Control I and add calculator. We're going to go to menu. We're going to go to probability. What am I getting for this? Not algebra, probability. And we're going to go to combinations. Probability, combinations. Okay, we get NCR. And what we're going to have for the 4th row is we're going to put our N first, which is 8. We want 8, and then comma, and then we get a bracket by pressing Control and this close parentheses. And for the 4th term, the first one is 0. So 0, 1, 2, 3 plus 3, we should get 56. So that's a quicker way we can get the 56 number. You got to be careful that in the 4th will be number 3, because the first one will be 0, the second one will be 1, third one will be 2, 4th one will be 3, and so on. So our answer is going to be 56, and then we're going to have 3x, and what you're going to have is our first term is going to be 3x to the 8th power. The second one is going to be 3x to the 7th, then 3x to the 6th, and our fourth term is going to be 3x to the 5th. So we're going to put 3x to the 5th, and then we're going to have negative 2y to the 3rd. So that's what the thing's going to look like. And if you can, and the numbers you're going to get is like 56 times 3 to the 5th power times negative 2 to the 3rd power, x to the 5th, y cubed. Now, it's going to be x to the 5th, y cubed. So these answer choices here, B and C, are out of the picture altogether. And you're going to end up getting a negative number. And so I think A probably is it. So we're going to have 56 times 3 to the 5th times negative 2 cubed. So 56 times 3 to the 5th times -2 cubed. Oops, I put minus here. That's not right. 56 times 3 to the 5th times, okay, now we go with this, -2 cubed. Syntax, oh yeah, here, let's get that syntax right. Cubed. My pen's a little good. So -108,864. Or 8,864. X to the 5th. Y cubed. What is that? Yeah, answer choice A. We've gone over these quite a bit, so I hope this one problem you get on your test, it'll be one you can do. Even if it takes you a little more time to do it, it's going to be worth it. 16, the Richter scale is used to calculate the intensity of an earthquake based on the amount of observed motion. Okay, so we have the formula. It says where A is the amplitude. What is the amplitude A of an earthquake that measures 5.75 in the Richter scale? So it says, here's the Richter scale. So Richter scale, we're going to put 5.75 equals 3.75 plus log. And log, I've explained, I hope you should know, is log base 10 of A. And you can work it different ways from here. One way I would recommend doing something like this if you get an equation is you can use numerical solve. That'd be just really easy to do. So numerical solve, as you press menu 3, 1, and we're going to say 5.75 is equal to 3.75 plus, make sure I get the right equation here, plus log base 10 of A plus log, and here's log, oops, that isn't what I wanted. I'll press control log, there we go, log base 10, and if you don't fill in 10, it gives you that automatically. I put A here, and then come to the right and put in comma A. Let's see what we get. I get 1.58. Somehow that doesn't look exactly right. What's wrong? 0.58. Is that right? Something looks wrong. Oh yeah, plus this 10 log A, that's what it is. Okay, I'll try it again. Menu 3, 1. Sorry about that. It's 3.75 plus, I don't want to put 10 log, I just want to put log base 10 of A, and then come over here, comma A. There we go, we get a 100. So A is equal to 100, and it's micrometers. Our correct answer choice is D. Next, 17, what are the sum of infinite geometric series? There is one thing you can do is you can kind of see a pattern, and you can keep on going with this pattern. One way that you can do this is if you find a common ratio and an initial amount, you can find it using the formula. And I think in all these sample problems, this is the hardest one of them all. I'm going to say a sub 1 is equal to negative 9/8. The next thing to do is to find r. Well, r is equal to a sub n divided by a sub n minus 1. So if it's geometric sequence, you can take any two of these together. So I can take 1/3 divided by negative 1/2. And dividing by a fraction is the same as multiplying by a reciprocal. So if I'm dividing by 1/2, by negative 1/2 is the same as multiplying by 2 over negative 1. And so the 1 over 1 cancel. So we're going to end up getting negative 2/3 as our r. So r is equal to negative 2/3. Okay, when you have that, we can go to our Acp Formula Chart, and you see sum of a finite geometric of an infinite. It's infinite geometric series. It's going to be a sub 1 over 1 minus r. You see that? So let's get this here. A sub 1 over 1 minus r. Well, in that case, we're going to have a negative 9/8 over 1 minus, and r is going to be negative 2/3. And so we can just put this in our calculator. And then we go here, we'll put in negative 9/8 over 1 minus, and then we're going to put in negative 2/3, and then we should get our correct answer here, which could be negative 27 over 40. And as of this day, in this class, we have not covered this yet. Or these formulas. Again, this would be maybe the toughest one we see in this sample set. Our correct answer choice is B. Next, 18 population small towns modeled by the equation P of n equals P sub 0 times quantity 1 plus R to the n. And this takes the form of the basic exponential functions we've talked about. And our base we've talked about is equal to 1 plus R. And R in this case is not going to be a percentage. So we have to change this 7.5 to 0.075. And so what we're going to see is, our base is going to be 1 plus 0.075, which is going to be 1.075. So that'll be our base. So and that looks like that could be either A or C. And I think our starting amount we're given is this, and we want the double. Our answer is going to have to be 90,000 on the left side. So our answer choice is C. Again, it's going to be A equals A sub 0. We have 1 plus R to the power of, here they're using n for number of years, so put n. That's to be 1 plus 0.075. C is our correct answer. 19, if the domain of f of x equals 2x squared minus 1 is restricted to 0, to infinity, which graph represents our inverse of this? Well, we can go ahead and see what that looks like and just go from there. So we're going to put 2x squared minus 1. Well, what it's going to be, it's going to be minus 1 will be right here like this. So it'll be something like this. Okay. 2x squared minus 1. Okay. 2x squared minus 1. Something like this. And really, between these two, I'm thinking it's going to look like, oh, I got that wrong. 2x squared minus 1 looks something like this. To me, it's going to be between B and D, really. And I do think it actually be B, perhaps. Let's go and put in the calculator. We're going to put, well, another thing you can do is look at, just take the inverse of this, look what it is. We say, okay, first step, y equals 2x squared minus 1. Okay, and then we go to x equals 2y squared minus 1, solve for y, add 1. We get 2y squared equals x plus 1, and then divide by 2. We get y squared equals x plus 1 over 2. And finally, we're going to get, if we take the square root of both sides here, we're going to get y equals plus or minus, okay, square root of 20x plus 1 over 2. And it looks like these are all plus ones. So you're going to look for the closest to this. And again, it's going to be a fine point between B and D. So that's what makes this one a hard one. So if we just go to our calculator, okay, we're going to talk about okay, Control I. We say it was x plus 1 over 2, x plus 1 over 2. So that's what it looks like. Let's see what we have here. Looks like it's more like D, doesn't it? Because it looks like we got 1 comma 1 here. This one here, B is skinnier. Let's go look at the table view. Control T. At 1 we get 1. Yeah, that's going to be answer choice D. So kind of a tougher one to distinguish here between B and D, but that is our correct answer. Next, 20. Which equation represents the horizontal asymptote for the graph of the function? And there's an analytical way to do this such that I'm looking at this and I can see instantly what the answer is, but we haven't gone over it that much. Let me go ahead and show you how to do this in the calculator. If you do Control I, add graph, we're going to just enter the function as given. So we get negative 6x cubed in the numerator. And then also in the numerator, minus 11x squared. And then we have plus 8. And then in the denominator, we have 2x cubed. And we have plus 5x minus 4. And then we hit that. And I hope it is apparent to you already, just looking at the part of the graph that we do see, is that we're going to have a negative number for our horizontal asymptote. And again, I know what it is. So anything that's a positive number, you can just get rid of already. Now, just to focus in on answer choice A, which is going to be our correct answer, if we go to a table view, Control T, or even better than that, I'm going to, instead of going to table view, let me do this. Oh man, I got rid of the thing. Sorry to do that to you. 6x cubed minus 11x squared plus 8. And down here we have 3x cubed plus 5x minus 4. Make sure I enter them right because I might have messed things up here. Yeah, that's right. Press that. That's what we get. Okay. If you just go to Trace, Menu Trace, Graph Trace, and you can go to the left or to the right. We're going to go to the right. Okay. You're looking for the Y values. Okay. Look at these Y values, what they're getting. Okay. So we get negative 2 point something. So that's one of the asymptotes. That's the one actually. I think I entered something wrong, didn't I? Let me go fix that. I'm just looking at that. I'm saying that's wrong. This is going to be 2. Look, that number was wrong. I'm saying, okay, that's. So here we are. I'm going to go to Graph Trace again. We can fix things. Okay. So we're scrolling, we get negative, we're going close to -3, okay? So the farther we get out to the right, we're going to get closer and closer, and we're not going to touch -3 exactly, but just getting infinitesimally close to that. So our correct answer to this one is definitely answer choice A. So that's all the problems in this sample set. It gives you an idea of the type of rigor that's involved. I'm also going to have one that's the pre-AP sample section, which is 22 problems. And between those two, you should be ready for just about anything in addition to what we've covered during the year. Good luck, and thanks for viewing.